Hello, this is Scholar Strife doing some math today in geometry. We'll be looking at circles, um, mainly properties of tangents of a circle. So first off, let's do some vocabulary. Here we go. A circle, hopefully you know what a circle is, is the set of all points in a plane that are equidistant from a given point. So let's say these dots on here on the edge of the circle, those would all be the points that they're talking about, and they're all equidistant from the center. So all points on a circle all points on a circle are the same distance to radius. Or center. The radius of a circle is the distance from the center to any point on the circle. And we call it R. A chord is a segment from one point on the circle to another. A diameter is a chord that goes through the center of a circle. Diameter. A secant is a line or ray that intersects a circle at two different points and continues outside the circle in one or both directions. So let's have a circle here. One secant can be like this. It hits 2 points on the circle and it goes on forever in that direction. Or we can have something like this. Hits those 2 points and goes on forever in both directions there. So these are both secants. A tangent is a line, segment, or ray that hits the circle at only 1 point. Touches the circle at 1. Cannot go into the circle. Stays outside. And tangents are also perpendicular to the radius. So this theorem 10.1, in a plane, a line that is tangent to a circle if and only if the line is perpendicular to the radius. So if we draw the radius and connect it to the tangent, right there, that means this angle is 90 degrees and this angle is 90 degrees. And then two tangent segments drawn from a circle, or drawn to a circle from the same point outside the circle, will be congruent. So this point here, so RS is a tangent, and TS is a tangent. And since they're connecting to the same point outside the circle, that means these two segments are congruent, same length. Alright, let's do some examples. Identify the special lines, segments, or rays for a circle. Okay, so BC, so we're looking at the segment BC. Okay, that's going from the edge of the circle. Maybe we'll use colors. So this red line here, that's BC. So the segment BC is called the radius. Okay. EA, the line EA, we know it's a line because of the double arrowhead. Let's do that. There we go. EA. Don't want to cover up the F there. So the blue line, that is considered a secant because it goes through the circle and hits the circle twice. Okay, the ray, DE. Remember, the ray is just, it starts at a point and then goes in a direction forever and ever. So we start at D and go to E forever and ever and ever in the direction of E. Okay, that would be a tangent because it only hits the circle once. Okay, and then the segment AB, I guess we'll just use black. AB is a special chord known as the diameter because it goes through the center. Example 2, use the diagram to find the given lengths. Okay. So, radius of circle A, so we just count 1, 2. Diameter of circle A, diameter is double the radius, so 4. Radius of B, so we go to B, go to the center of B, and then go 1, 2, 3, 4. That's the radius, so double it for the diameter. Example 3. Tell how many common or shared tangents the circles have and draw them. So a shared or common tangent is a line, segment, or ray that is tangent to both circles at the same time. For example, if we did something like this, if I can draw it right, there we go. So that would be one tangent, one common tangent, or one shared tangent. This would be another. Now, is there any way for me to draw another commonly shared tangent? Yes, there's one more, because technically in between, they only touch at one point. So that would work. So this one has 3. This next one is just 2. Nope. Part C, this one is just 1. See, that tangent hit both circles. Okay, check part 1. Tell me how many common shared tangents the circles have and draw them. So part A, we have 0. We have one circle inside the other. We can't draw a line that's tangent to both circles because it'll have to cross through one of the circles in order. So none. Part B, we have 1, 2. This one here. Oh, I messed up. Let's do this in a different color. So I'm trying to draw this here. kind of like an X. This one has 4. 4 common or shared tangents. Example 4. In the diagram, RS is the radius of circle R. Is ST a tangent to R? Use a Pythagorean theorem or a triple to determine if triangle RST is a right triangle. So if ST is a tangent, then that means this would have to be a right angle. And if we have a right triangle, we're allowed to use Pythagorean theorem. So A squared. So once again, A, B, C. C is the longest side. Why does that... Oh, I didn't see that there. C is the longest side. A and B are the 2 legs. So 5 squared plus 12 squared is equal to C squared. C squared, so they give us that this piece here is 8. Okay, and the radius is 5, so this is 5 plus 8, which is 13. So C is 13, so we're going to square it. So if this works, that means RST is a right triangle. If this doesn't work, then it's not. So is 25 plus 144 equal to 169? I guess it is. Triangle RST is a right triangle. Okay, let's do that again. In the diagram, RS, this is the radius is 12. Is ST a tangent to R? Okay. So this is 12 plus 7. And they want to know if ST is a tangent, so my right angle would be here if this is true. Okay. So A squared, let's say 12 squared plus 16 squared, is that equal to 12 plus 7, which is 19 squared? Put a question mark. 144 plus 256, does that equal 361? 400 does not equal 361. Therefore, no. ST is not a tangent. And that means this is not a right angle. Alright. In the diagram, B is a point of tangency. Find the radius R of circle C. Use Pythagorean theorem. Okay. So they tell you that B is a point of tangency. That means AB is tangent, and that means that is a right angle. Okay, and then this is going to be A. This is going to be C. It's always opposite of the right angle. It's always the largest side. And this is B. So A squared, which is R squared, plus 77 squared is equal to R plus 49 quantity squared. Got to put the parentheses because this whole line is R plus 49, and that's what we're squaring. Okay. So I have R squared plus big number 5,929. Okay, and then remember, this is R plus 49 times the quantity R plus 49. So we go ahead and do FOIL. And that'll give us R squared plus 49R plus 49R plus 49 times 49, which is 2,401. So FOIL. Okay. Now we're going to get r squared plus 5,929 is equal to r squared plus 98r plus 2,401. Okay. Luckily, our r squareds cancel, because if I subtract 1 r squared from both sides, they go away. And so minus r squared, and then I'm going to move the 2,401 over to the left side. Okay, so I'm going to get 98r on the right. On the left, I'm going to get 3,528. So r is equal to, when we divide both sides by 98, 36. So the radius of the circle is 36. Alright, example 6. QR and QS are both tangents to circle C. Okay, so they're talking about RQ or QR, this line here, and SQ or QS. They are both tangents. So we have that theorem that says if they are both tangents and they're connected by the same point, then those segments are congruent. So the 32 is equal to 3x plus 5. So we're going to subtract 5 from both sides. 27 equals 3x. 3 times what number is 27? That is 9. Okay, let's look at some more examples here. Okay, K is a point in tangency, so that means this is a right angle. That means we can use the Pythagorean theorem. So this is A, B, C. C is always opposite of the right angle, the longest side. So we're going to put out what we know. R squared plus 56 squared is equal to r plus 32 squared. Okay, so I'm going to get r squared plus 56 squared, which is 3,136, equals r squared plus 32r plus 32r plus 32 times 32, which is 1,024. Okay, I'm going to do the same thing I did last time. And just in case you missed it, when I'm trying to both sides have r squared on it so we can get rid of them. And then I'm going to move the 1,024 over to the left side. Okay, so on the right side, I have 32r plus 32r, so that's 64r. On the left side, 3,136 minus 1,024 is 2,112. Okay, 64 goes into that 33 times. And that's my radius, 33 units. RS and RT are both tangents to circle C. Find the values of X. Okay, so because they are both tangents, that means these are the same length. So that means 49 is equal to x squared. To get x by itself, we do the opposite of squaring, which is square rooting. Okay, what times itself is 49? That is 7. Now you might think, well, this is supposed to be plus or minus 7 because negative 7 times negative 7 is also 49. But x cannot be negative 7 because that would mean our length would be negative, and we don't use negative lengths. So my answer is x equals 7. X cannot be negative 7. And that's the wrong symbol. It's 1 slash. Not a curvy slash, just a slash. Okay, not possible. No negative lengths. And I hope that helped you out. Have a good day.